Alright, today we're going to continue on with what we've been working on with graphing different types of trig functions. So right now, what I'd like you guys to do is look at number 2. What does number 2 deal with? Like the cotangent, right? Cotangent at 3 pi over 2. So I'm going to show you guys how to use your notes. So we're going to go down here. We're going to look for the notes for cotangent. Scroll them down right here. Oh, that's tangent. Let's look at cotangent. So there's my cotangent of x graph. So I'm going to rewrite problem number 2. And it asked you to evaluate where the cotangent was equal to, what is it, 3 pi over 2? Alright, so 3 pi over 2. So what I'm going to do is I'm going to look at my graph right here. And right here we are at a 0. Right here, this is at pi over 2. So if you want to, you could write notes on your notes if you want to. That's pi over 2. This is pi. This is at 3 pi over 2, and that's at 2 pi. So it looks like my y value, or what it would equal, would be right here would be a 0. Now, obviously there's a picture of a graph, but even easier, if it said evaluate what, cotangent of 3 pi over 2, some of you watching the video was like, dude, come on man, just right here. At 3 pi over 2, what is it equal to? It's equal to 0. So you could also use the table. So you can use the table, or you can use the graph to help you guys answer those questions. So I'll do one more. See if it makes sense. Let's go all the way back up to the top. So right here it says, find what? The cosecant of theta equals 1. Oh, I was right, wrong one. Right back. The secant of 4 pi. Here we go. Let's go. Secant of 4 pi. Let's go down to our secant graph. That's all the way at the bottom. Okay? So this will be kind of fun. Get your graphing calculator ready, okay? Get your graphing calculator ready. I'm going to zoom out a little bit. There we go. So right now, I'm going to write the secant at 4 pi. So right now, what I want you guys to look at is this graph right here. I want you to look, as I draw this, that graph right there. What does it start at, this dotted line? It starts at a 1, and it finishes right here at a 2 pi. What does this section look like? So the cool thing about a secant graph, that is attached right here. What you're dealing with, this graph right here is the cosine of x graph. So what I want you guys to do right now, we're going to turn on our graphing calculators, and what we're going to do is we're going to graph this together. So turn on your graphing calculators. I'm going to go from negative 2 pi to positive 2 pi. I'm going to make my x scale at pi over 2. I'm just going to go from negative 5 to positive 5 and make my y scale 1. I'm going to hit the y equals button. And in red, what I'd like you to do, in red, say you're going to type in the cosine of x graph. All right? So type in the cosine of x graph. So if I were to graph this by hand, without the graphing calculator, if I was going to graph this by hand, honestly, this is what I would do. I would make my cosine of x function on my graph paper. That's what I would do. And then, from there, I want you to put, from there, I want you to see these points right here. This is where I would draw in all of my asymptotes. I'll explain in just a second while I do that. So right now, if I was given the task of drawing a secant of x function, I would start by drawing what first? Cosine of x function. That gives me some boundaries to help me with it. Watch this. Here's what I'm going to do. From here, I know my secant of x function is going to go up, it's going to hit that cosine of x function, and it's going to go back down. This is the pattern. It goes down, it hits this part right here, and then it goes back up. Right here, it's going to go up, it's going to hit, and it's going to go right back down. Here, it's only going to graph this part of it, and right here, it's only going to graph this part. This is the pattern. So now, in green, what have I graphed? By hand, I've graphed the secant of x function. By the way, you can't type that in the graphing calculator the way that. But here's what you can do. You can write this. 1 divided by the cosine of x. So right here, I want you guys to understand, these mean the exact same thing. Y equals 1 divided by the cosine of x is the same as y equals the secant of x. So when I hit y equals, and I say, you know what, I'm going to do 1 divided by the cosine of x, and hit graph, now look what happens. Okay? Now, what does the graphing calculator not do? It doesn't draw in all of your what? Asymptotes. Yeah, it doesn't draw them all in. But hopefully you can see that right here, I'm not going to draw all of them in, okay? But hopefully you can see there's an asymptote right here. I can get it straight up and down. Apparently I'm not very good at drawing straight lines. There we go. So where am I could draw in a couple more. But right here, where are my asymptotes located? My asymptotes are located where? At pi over 2, and also where? At 3 pi over 2. So this right here, this is how you build your secant of x graph. So now let's use this to help us evaluate our problem. What was our problem? Where is the what? Where is the secant, what's the secant of what? 4 pi. So if I wanted to, I could just change my window and say, you know what, I want my x maximum not to be at 2 pi, I want it to be at 4 pi. Then you hit graph. Okay. Check it out. Right here, what did I say my x maximum was? I said it was at a 4 pi. Hey, look, what's my y value right there? Is that a 1? So, the answer to that, the secant of 4 pi equals 1. And that's your answer. Hopefully that process right there made a little bit of sense as far as how we were able to figure it out. Now this is the part where I need you guys not just to look at the graph, I want you guys to look at the tables and the definitions, like the properties of. So right now, I want you right now, we're going to, how about this? You choose 5, 6, 7, or 8, and I will do one of them, but not all of them. Choose which one you want me to do. So we say 7? 7, okay. 7, the cosecant of theta. Where is the cosecant of theta always equal to 1? So right now, I'm going to go to my cosecant graph. Okay. Right here. Here is my cosecant graph. So right now, what I'm going to do is I'm going to put a point right here. I'm going to put a point right there. And where am I located? Right there. I am located at what? Pi over 2. Where am I located right here? 3 pi over 2. So in my cosecant of x graph, when is my y value always equal 1? What would you write down? Well, if I were a student, I would just write this down. That's your answer. Your y value is equal to 1 when x equals pi over 2 plus 2 pi n, where n is an integer. Well, that's just too much. So you could say at pi divided by 2 plus 2 pi, 2 pi n. And what does n have to be? N has to equal an integer. That's your rule. that's where your y value is always equal to the number 1. So what was our question? That was what, number 7? Number 7 said, where is the cosecant of theta always equal to a 1? The cosecant of theta is always equal to a 1 right here when this is the case. So literally, what does n have to be? What's an integer? 1, 2, 3, 4, 5, or negative 1, negative 2, negative 3, negative 4, negative 5. Okay? Where n is an integer. Okay, I'm going to do one more real quick. I'm going to look at this one. It says, find the values of theta for which each equation is true. So right now, I'm going to look at the tangent of theta equaling 0. So I'm going down to my tangent node. So here we go. This right here, I'm going to stop. So right now, we got to look for a pattern. Look for a pattern. When is the tangent of theta equal to 0? So I'm going to highlight everywhere where I see a 0, where y is equal to 0. So I see a 0 right there, I see a 0 right there, and I see a 0 right there. Now where is that happening? That's happening at a negative pi. That's happening at, I know it's kind of hard to see, but that's at 0 pi, and it's happening at 1 pi. Well, right there, and right there. So if I wanted to find a rule that encompasses every single possible answer, those are my what? Those are my x-intercepts. Where are they located? At pi times n, where n is an integer. So where is the tangent of theta equal to 0? Well, technically, it's equal to pi times n, where n has to be an integer. Just remember, whenever you see the word x-intercept in any type of situation, an x-intercept is when your y value is always equal to a 0. So anytime you see x-intercept, from this moment on until you pass away into the next dimension, your x-intercept, your y value will always be 0. So some of you are probably still asking, well, what's my answer? This is your answer for problem number 5. Now, the last thing we're going to do today in this class is we are going to graph this function right here. No, we're not going to graph. I'm going to help you set up number 10. We're not going to graph it all the way. Okay? So here we go. Number 9. What the very first thing that I'd like you to do is I'm going to do this and see if you guys can understand why I'm asking you to do this. When I do a dotted line, think of a nice thin line right there where it says +1. The reason why I'm doing that is because of this little guy right here. This graph has actually been shifted up 1 pesky unit. So it's gone up 1 unit. All right? So that's what I want you to do. Next thing I want you to do is we're going to write x minimum, x maximum on your paper. We're going to write the x scale. And it's on an exclamation point. I meant to do a colon. That's better. Oh, much better. All right. So what is my x minimum? I'm going to put a negative pi. My x maximum over here is at a positive pi. This is where it gets a little tricky. Halfway between a 0 and a pi over 2 is a pi over 4. If you are an overachiever, you can label this as 3 pi over 4. This is 1 pi over 4. This is 2 pi over 4, 3 pi over 4, and 4 pi over 4. Pi over 2 and pi are just reduced. If I'm blocking you, apologize. So there's all the little tick marks labeled. All the tick marks now there are labeled. So now hopefully you understand why I put my x scale is actually at pi over 4 in the graphing calculator. For y minimum, put it -2. For y maximum, put at 4. And for the y scale, just leave it as 1. So we're going to go ahead and just type all of this in right now. Clear this out. Clear this out. Hit window. Going from -pi to +pi. And what did I say my x scale was? That's right, pi over 4. I agree. Well, I understand how it could be confusing. I mean, it's not like I wrote it down anywhere.
You did. You did.
Well,
I didn't see it.
oh, okay. Well, there we go. So there we go. And don't worry, that wasn't immortalized on YouTube. Okay. So we're at -2. We're at +4. And we're at y scale of 1. So here we go. -pi, +pi, pi over 4, -2, +4, 1. Once you have those plugged in, then and only then do you want to type in your equation. Hit y equals. And I'm going to look over here at CJ's paper because there we go. So you hit the tangent button. And then you type in, you can't type in 2 theta, but you can type in 2x because x is theta. Then you're going to put plus pi. Then you're going to close the parentheses, and then you're going to put +1. But what I'd like you to do next, before you hit graph, some of you may have already hit graph, but before you hit graph, what did I tell you to draw at the very beginning? Nope. Just a line at 1. So put y equals 1 right there. So type those in, and then and only then hit graph and take a look at your graph. All right, so there's our graph. Now, this is the part that's a little bit tricky. It's like, well, how in the world am I supposed to take this graph and do what? Draw. So we're gonna show you how to do it. So here we go. There's a reason why I put this dotted line right here. Let's go back. Take a look. What I'd like you to do is, you guys see this point right here? This point right here? All these points that I'm doing right here? Right now, I'm going to show you where those are. This is at a -pi. Alright? This right here is at -pi over 2. This is at a 0 pi. This right here is at pi over 2. And over here, this is at, not a 2 pi, so this is at a pi right there. So I'm going to plot them together with you. Here we go. I got one right there. I got one right there. One right here. One right here. And one right here. Right here. Alright? So there we go. Plot them just like that on your paper. Alright, now that you have this plotted, go back to your screen. Now, you guys can't see it, but right here, where is this located right here? This is at what? -3 pi over 4. This is at -pi over 4. I need you guys to draw in some asymptotes. It's like I could say it as much as I want, I don't get in trouble. Asymptote. So right now, draw on your asymptotes, everybody. Well, that's what you're supposed to do. You're supposed to draw on the asymptotes right here. So go back right here. Take a look at it. Alright? We're going to draw on some asymptotes right now. Right there. Draw on the asymptotes. Make sure they're nice and straight. Man, gotta straighten these asymptotes up. Nothing worse than a crooked asymptote. Don't worry, nobody watches these anyways. Alright, so right now, I realize that this one is not very good. Hold on. I know some of you are like, students are so critical of me sometimes.
Has anyone ever written anything bad to you on your YouTube?
If they did, I've never read it. So watch it. Don't read the comments. Maybe if somebody wrote something down. Like, Mr. Moo, that was crooked. Well, so was your nose, but you still have the anyways. Alright, so right now, I know. All right, so let's go back, take a look at this. Okay, so now that we have our asymptotes, now this is what I want you guys to do. I want you guys, I'm going to do a different color here, I'm going to do green. This is what I want your final graph to look like. Here we go. You are going to, from this asymptote over here, get really close to it, then let it start bending right through that point, going, once again, right through this point, and then let it go what? Let it hug this part of the seams on this board. All right. Oh, that's not good. That's not good. That's all right. Just, you guys should be able to do a little bit better sketch than me right here. Oh, wow, that was really bad. Okay? Now, you'll notice that right here, at negative pi, I'm technically only going to see this portion of the graph. And at here, positive pi, you're going to see it come up, but then it's just going to stop right there. So this is your final answer. What am I looking for? I'm looking for this midline right here at a 1, because that's the vertical shift of a 1. And then where I'm looking for where all the asymptotes are located correctly. That's what that's what you're going to be doing on your own for problem number 10. Now I'm going to help you with problem number 10, just typing it in. So here's how you would need to type this in when you need to get this graph done. So go to y equals, okay? I'm going to clear this out. This is the final thing I'm going to do. I'm going to look over Cameron's shoulder because he still has his workout. He doesn't put things away like CJ has. All right, we have cotangent. So I'm going to do 1 divided by tangent because that's your cotangent. So 1 divided by tangent. For this I'm going to do x divided by 2. Is it minus? Minus pi divided by 2. Then you better close that dadgum parentheses and then put minus 2 at the end. Then and only then can you graph it. Now here's what I haven't changed. I haven't changed my x minimum and x maximum, but that's how you type in your function. So you have to change your what? What are you going to have to change? Your x minimum and your x maximum, which means you're going to have to go from negative 2 pi to positive 2 pi. So what are we going to, then you're going to graph. You kind of see what it kind of looks like. That's not your final answer because I didn't change all of my Windows settings the way yours need to be. Okay? But this is how you type it into your graphing calculator. I'll leave it up there. You all have a fabulous day.